Good afternoon everyone. In today's class we will try to see how to perform FM using LabVIEW. Further, first we need to understand what is the equation that we are going to build using LabVIEW. So let me show you the equation. So we'll be trying to build for singleton modulation. So S of t is given as AC cos of 2 pi fct plus beta sine 2 pi fmt. So let us assume this AC as 1 for our ease of building the blocks. So your final equation will be cos of 2 pi fct plus beta sine 2 pi fmt. So to build this equation using LabVIEW, you need to further expand this equation using the formula cos A plus B. Okay, so this becomes cos of 2 pi fct into cos of beta sine 2 pi fmt minus sine 2 pi fct into sine beta sine 2 pi fmt. So now you will be trying to build this particular simplified equation using LabVIEW. So let us see how to build this. We will go step by step. So first we will try to create this one, beta sine 2 pi fmt. Then using cos and sine blocks, we will try to build this cos of beta sine 2 pi fmt. And then we will multiply these two. Again we will build the multiplication between these two, and then finally we subtract. This is the flow we will be following. So let me show you how to do that. So you already know how to get sine, cosine or square signal. So you just need to right click on the block diagram, go to express, input and simulate signal. Okay, now our first goal is to build beta sine 2 pi fmt. So let us assume our FM value is 10 Hz and AM I'm also taking 1. Okay, now we need to build first sine 2 pi fmt, and then we will be using a multiplier block to do beta sine 2 pi fmt. So now it is in sine, just give frequency as 10, 0 phase, amplitude is 1. One thing you need to note here is samples per second should be 10,000 and also this should be 10,000. Press OK. So this is your sine 2 pi sine 2 pi fmt. Now you need to have a multiplier to perform this beta sine 2 pi. Now one input will be going here, the other one I will create a control. Let me rename this. So you can see the subsequent block has been appearing in the front panel. Let me take beta as 1. Okay, now our beta sine 2 pi fmt is done. The next thing we need to do is we need to apply this to our cosine and sine blocks. So we cannot directly use these simulate blocks. We need to use separate cosine and sine functions that are available as part of trigonometric functions in Express library. So let me show you how to go to that. Right click, Express, arithmetic and comparison, then math, then trigonometry. So in this you need to use these two to build cos of beta sine 2 pi fmt and sine of beta sine 2 pi fmt. Let me take cos and also sine in the same way. So these two blocks are used because we need to build something like this. So we need to build this part, cos of beta sine 2 pi fmt, where you will be giving your beta sine 2 pi fmt as an angle to this cosine or sine block. So to give this as an angle to this cosine or sine block, you need to use these different blocks called as cos and sine blocks. Okay. Now to build cos of beta sine 2 pi fmt, you just give this as an input to this cos block. Similarly, to build sine of beta sine 2 pi fmt, this is the way you can do it. Now the outputs of these two are sine beta sine 2 pi fmt, and this one is cos beta sine 2 pi fmt. Now you need to build cos and sine carrier signals, that is cos 2 pi fct and sine 2 pi fct. Just right click, express, input, simulate signal. So since this is carrier, I will be giving 100, and let me take this as sine 1000, or sorry, 10,000, again 10,000, press OK. So this builds me sine 2 pi fct. Okay, in the equation you can see that we require sine 2 pi fct and also cos 2 pi fct. So this is done. Now I need to build this. So again right click, express, input, simulate signal. Now that is cos, so you need to give phase as 90 and the frequency is 100. Again samples per second is 10,000 and number of samples is 10,000, press OK. Okay, so this is for sine, this is for cos. So let me recheck whether this is cos. Yes. Now what you need to do, you need to multiply the outputs of this and also this. So you just right click, put a multiplier, again one more multiplier on the bottom of your screen. Then you just need to give inputs. One input is coming from cos 2 pi fct and the other one is cos of beta sine 2 pi fct. Similarly, you need to extend the same for the bottom ones. Now we are done with this multiplication of cos terms and multiplication of sine terms. Now you need to subtract them. Okay, to subtract them you use a subtractor. Then one input will be coming from here, the other input will be. Now the output of this subtract block is what is your FM signal. Okay, let me show you how it looks like. Give a graph indicator. Before showing you, I will also plot the carrier. So let me take this carrier, create graph indicator. Okay, now when I press run, I should be able to see FM signal. So it is not clear. Let me zoom in. Okay. So this is the modulated signal. Let me further increase this so that we can clearly visualize the variations. Okay, so this one is the carrier and this one is the modulated signal. Now you can see there is a increase and decrease of frequencies, which is the basic principle of FM signal, where you will be having Fmax and Fmin, and also this increase and decrease of frequencies is with respect to the message signal. Whenever the message amplitude is high, you will be having Fmax. Whenever the message amplitude is less, you will be having Fmin. So such type of variation in frequency is observed in FM signal, and you can clearly see that there is such variation in the graph. Okay, now we will also try to plot the spectrum of this modulated signal. For that you need to right click, go to express, signal analysis, spectrum. So we will be basically interested in spectrum of modulated signal rather than message signal. So some of the students are basically plotting the message signal spectrum. It is not wrong, but we are not interested in visualizing the spectrum of message signal. So we are basically focusing on plotting the spectrum of modulated signal. So for that you need to give modulated signal as an input, and output you need to see from FFT RMS. So this is also one of the mistakes that I observed in the lab. Most of you are seeing the output from phase, which is wrong. We require graph indicator at the FFT RMS. Create graph indicator. So the spectrum of FM looks something like you will be having a carrier frequency and multiple number of sideband frequencies. So those multiple number of sideband frequencies basically depend upon the beta value. So one thumb rule is you need to get more than 2 side frequencies whenever you give beta greater than 1. Okay, that is the thumb rule. So since our beta is greater than 3, you should be able to see more number of side frequencies. Let me run this, and since this is a very large range, I will trim this range or zoom in. So for that you can see that my frequencies are around 500. So I will make this as 500 and press enter. So you can see that there is a carrier frequency at 100 and all the side frequencies are at Fc plus and also at Fc minus. Okay, so these number of side frequencies basically depend upon the beta value. So the only thumb rule you need to keep in mind is for wideband FM, since beta is greater than 1, you will be getting more than 2 number of side frequencies. Okay, that is what is the thumb rule. So let me show you what happens when I decrease this. What is the effect on the side frequencies. So again I will zoom. So now you can see the number of side frequencies has been decreased. Okay, so this is how you will be generating FM modulated signal and also display the spectrum of FM modulated signal. So whenever you are taking screenshots, you need to keep these values appropriately so that you can visualize the variations, then only you take the screenshots. Okay, now we will try to see the demodulation. So for this demodulation we require 2 extra blocks from RF communication. Okay, so I will first place those 2 blocks and then we will have an explanation regarding how to do the demodulation. Right click, RF communication, modulation. Since we are doing analog modulation, you need to go to analog block, and in this we are doing demodulation. So you need to choose this demodulation, and the first block we will be using is empty down convert passband. Okay, next right click, RF communication, modulation, analog, demodulation. Then we will be using empty demodulate FM because we want to demodulate FM signal. We will be using them. Now when you scroll your mouse on this particular block, that is empty down convert, you will be seeing different options: real waveform, carrier frequency, passband band, advanced filter parameters, etc. For our case we only require these 3. The first one is real waveform, passband bandwidth, and the third one is carrier frequency. So real waveform will be coming from your subtractor block, output of your subtractor block, that is nothing but your FM modulated signal. Okay. Carrier frequency you can create a control. So this carrier frequency should be same as that of your transmitter side carrier frequency, which is nothing but 100. So you need to give that in the front panel. Then the last one that you will be selecting is passband bandwidth. Right click on the create control. Okay. So by default you can keep this as 1 Hz, or else you can use the formula, that is 2 of delta f plus fm, to take this value. So let us take the beta as 1 and fm as 10, then this passband bandwidth will become 40 because beta is 1. So 2 of delta f plus fm will give you, let me show you how we are getting it. So the transmission bandwidth or bandwidth is given as 2 of delta f plus fm. So if you take fm common, this becomes beta plus 1. Since beta is 1 and fm is 10 in our case, so this becomes 2 into 10 into 1 plus 1, that is nothing but 40. Similarly, delta f is given as beta into fm. So beta in our case is 1 and fm is 10, so this becomes 10. So delta f is 10, okay, and fm is already 10. So this is the deviation one, and this is your bandwidth. So you can choose your bandwidth depending upon this also, so no issue. So I am taking 40. Now again scroll on this last block, so you can see FM modulated waveform that should be connected to down converted waveform, okay, and FM deviation just now we had calculated, create, control, FM deviation is, we are getting it as 10 Hz. Now the output of this is your demodulated waveform. So what should be your demodulated waveform? It should be a simple cosine signal, okay, create, indicator, okay. Now whenever I create indicator, you can see that we are not getting the graph indicator. So for this what you need to do, you just delete this, place graph indicator in the front panel, okay. Now once you get this in the block diagram, you just connect this waveform graph to the FM demodulated waveform. So please listen to this carefully. Whenever you are not getting any graph indicator directly in the block diagram, you need to place that graph in the front panel, and after placing the graph in the front panel, then you can connect to the output of this FM demodulator. So to place graph indicator in the front panel, you just need to right click, go to this model, and then waveform graph, select the waveform graph, okay. So let me run this, okay. So whenever you are having this trouble of change in the axis, you just right click on the properties, sorry, just right click on the graph, go to the properties, then in the scales you can uncheck this auto scale and you can give whatever the limit you want, press OK. Similarly you can do this for the other waveforms, so that you can have fixed scale whenever you run the LabVIEW block, okay. So this helps us in having a fixed scale. Go to properties, so this I am giving it as 500, press OK. So this okay, the front one I will decrease somewhat because it is showing lot of distortions in the starting stage. So to remove that from the visual part, we can increase this 0.05 and press OK. See, now the first one is the modulated signal, second one is your carrier signal, this is your FM modulated spectrum, and this is the demodulated signal, okay. So you can also increase this beta and see what happens. See, the modulated signal is same, but the number of side frequencies in your spectrum has been increased. And similarly you can see, now you can clearly visualize the frequency increase and decrease in your modulated or FM modulated signal. So let me also plot the original message signal. So what will be my original message signal? So this is coming from my original message signal, which is nothing but cos 2 pi fmt. So why this becomes my original message signal? Because if you closely observe the equation of Fm, cos 2 pi fct plus kf integration m of t dt. So we need to perform this integration. So if my signal here is sine 2 pi fmt, that means my original signal is cos. Okay, so we will try to plot that and see what is happening. So to plot that, what you can do is you can give that directly to this waveform. So how to do that? First you need to place that block, go to express, simulate signal, take cos because that is my original signal. This should be 10,000 and this should be 10,000. Now you can remove this and you can use a block in the express that is present in this signal manipulation, merge signals. Okay, you place this one, you can give it as modulated signal, the other one you can give this message signal. So this basically helps us in visualizing the impact of message amplitude on the final frequency of the carrier. Okay, so let me run this. So now you can see the red one is your message signal and the white waveform is your FM modulated signal. So let me increase this so that you can clearly see the impact. So we already know that whenever the message amplitude is maximum, you need to have the maximum frequency, and whenever the message amplitude decreases, the frequency of the carrier signal will decrease. Okay, so you can see that at minimum amplitude, that is -1, we are having the least frequency. So this way you can plot both the waveforms, that is message and the modulated signal, and you can see the variations, how the amplitude is impacting the carrier frequency. Okay, I hope you understood how to build the block diagram for the generation and demodulation of